はじめまして、皆さん。私はカズリン・フィールズと申します。今日クラウドネイティブとオープンソースのことを話します。私は少し日本語で話せますけど、英語の方がいいですから英語で変わりますようにSo, welcome again, everyone. I am Kaslin Fields. クラウドネイティブミートアップ東京へようこそ。So today I'll be talking about cloud native and open source technologies. And the artwork in this presentation was done by myself. If you're interested in more technology comics, you can find my comics at Kaslin.rocks. Okay, and let's get started, I guess. So to talk about cloud native, I think it's important to talk about lift and shift, which is the idea of moving your on-premise applications to the cloud as they are. So if you do lift and shift, you take your application as it's running in your data center and you move it to the cloud and basically run it in exactly the same way. However, this doesn't take advantage of a lot of the unique capabilities of the cloud. And if you want to use those unique capabilities, then those architectures are referred to as cloud native. They use technologies which, while you could use them in your data center, they usually work best in cloud environments. And you'll notice that cloud native and DevOps are often mentioned together. If you were at my presentation earlier today, then you'll recognize a lot of this. I promise some of it will be different, though. So DevOps and Cloud Native are often mentioned together. And that's because the concept of DevOps works very well with the concept of Cloud Native. DevOps, like a lot of Japanese contractions, is a contraction of two words. ウォープロのようなものです。デベロッパーとオペレーションズの言葉です。So, 時々日本語で。So combining these two words together is similar to what is actually happening. You're taking your developers and your operations and you're having them work more closely together. デベロッパーズとオペレーションズの人、もっと近くに仕事をしますように、それは DevOps のものです。And the more traditional ways of doing things without DevOps, developers and operations sometimes have some friction between them. Developers want to get their infrastructure really quickly, and sometimes operations people kind of seem to get in the way from the developer's perspective, and operations people are always getting upset with developers because their code broke something and they get called in the middle of the night on pager duty. So this DevOps, or bringing the two disciplines closer together, makes things a lot smoother. And cloud native is how you do that. So I wanted to explain the Cloud Native Computing Foundation a little bit. So this is a Cloud Native Computing Foundation associated meetup, so many of you may know about the CNCF. But the CNCF is an organization which has a goal to promote cloud native technologies in the world. It's not related to any specific corporation or company. It operates independently to support open source initiatives and support the adoption of cloud native technologies in business. So Cloud Native Compute Foundation owns many different types of cloud native projects, and they help to promote those projects across the business world. To give you an idea of what that looks like, this is the cloud native landscape. たくさんプロジェクトがありますよね。目が痛いのように。So there's a whole lot on here that the Cloud Native Compute Foundation covers. Today I won't be covering all of that, but if you notice, there are some different sections, different categories of technology. So we're going to talk about some of those technology categories today, which is basically what this slide says. So as you saw in the diagram, there's a lot to cover. And if you want to learn more about any of these specific categories, you can always go to the CNCF's website to learn more. So today we're going to use an analogy to do this. So, クラウドランドへようこそ. We're going to use the analogy of an amusement park or a festival. 祭りのようなアナロジーです。Because the cloud is a unique environment. So when you think about a festival or an amusement park, what are the things that you get excited about? For me, I get excited about the food. So, delicious and exciting food. So today we're going to talk about these different types of cloud-native technologies as different types of food that you might see at a festival or an amusement park. And we're going to compare some of the key features of those technologies to key features of the foods. An important part of this analogy is you could make these festival foods at home if you really wanted to, but there are reasons that you don't. They're really messy to make, or they really work better when you buy them in bulk and make them in bulk. So they work well for large-scale crowds. And there are all sorts of other reasons why festival foods are just better at the festival rather than at home. And this is similar to how cloud-native technologies tend to work better in the cloud. You could deploy them in your data center, but there are certain aspects of the cloud that make them more useful, more robust, better to run in the cloud. So the first technology we're going to talk about is container registries. So if you're familiar with containers at all, you'll be aware that containers are well known for being a lightweight way to package your application and all of its dependencies, and then you can move that application to different computers very easily. Before you have a container, you have a container image. This image defines what the container will look like when you spin it up. So these images are kind of like popcorn kernels. They're very dense. They have a lot of information within them. There are also many different types of popcorn. I'm not sure if you knew that, but it's pretty cool. So you can store many different types of container images in a container registry. And each container can be used to create many containers. Each container image can be used to create many containers, yes. And like I said, it's repeatable. You can deploy containers on many different types of systems and all of that kind of thing. And just like popcorn kernels are much easier to transport than popped popcorn, container images will be much easier to transport to wherever you need to spin them up. Which brings us to Kubernetes. So a popcorn kernel by itself is not very delicious. Popcorn no kernel wa 面白くない、美味しくないですよね。面白いだと思いますけど。でもポップコーンの方が美味しいです。そして友達と一緒にシェアリングができます。So when you pop up the popcorn into its kernels, you get a lot more popcorn. You can easily share it with your friends. So this is sort of like Kubernetes, where you can spin up your containers and you can have applications for many different teams running on one Kubernetes cluster. And also, popcorn is really easy to eat. It's really easy to carry around in its little bag. And Kubernetes makes it a lot easier to manage all of your containers. Just carrying around a whole bunch of popcorn in your hands would not be very fun. So Kubernetes makes managing those workloads much easier. Now, serverless. Serverless が聞いたことがある方は いますか？あ、そうなんですね。それはいいですね。So, serverless is kind of like caramel popcorn. It's pre-popped, it's pre-candied, and it's pre-packaged. So technically underneath the covers, you're using containers to run your code, your applications. But you don't really care about that. All you care about is the code that you want to run. So in that way, it's like this caramel popcorn that's already been popped and candied and packaged. In the cloud, a serverless managed service allows you to run your code or your applications without having to worry about the underlying infrastructure, and you also only pay for it while it's running. In this way, it's like pre-packaged caramel corn. It's individually packaged so that you only get what you need. And an example project is the FN project. This is one that Oracle used to base our managed service off of, but this is an open source project. So you could run a serverless system within your own data center if you wanted to, or you could run it on any other cloud because it's open source. And what this allows you to do is to provide serverless style services to your teams without having to actually use a cloud managed service, which you might be afraid of lock into different clouds and things like that. So let's take a look at what that looks like. So imagine you're with a group of your friends and you have a photo booth app on your phone. And you take a selfie with your friends and that image gets uploaded to storage in the cloud. You can set a trigger to say when an image is uploaded to this storage, run this function on that image. And that function will do some processing. So then once the function is finished running, it produces this new processed image which has shines and sparkles and much brighter colors. もっと美しい写真になります。そのようなものです。So the function was the part that did all of the processing and applied the filters. So now let's talk about service mesh. So we just talked about containers and Kubernetes and serverless, and running all of those things in production requires the use of many different services. The Cloud Native Compute Foundation has many of those services under its umbrella that are available open source, but finding all of the services that you need and putting them all together on a system is pretty difficult. So a service mesh is kind of a one-stop shop. Or in this case, hanami dango. It's got 3 different flavors on one stick. So the service mesh contains many different services that you may need to use for your containerized architectures, all in one place. It includes things like proxies, monitoring, logging, tracing, and all sorts of other good stuff. And I've lost my... Oh, that's why. Sorry about that. And some examples are Istio and Linkerd. So Linkerd is owned by the CNCF. Istio is another common service mesh that you'll hear talked about. And I do presentations on those too. So if you would like to ask questions, feel free. So Terraform is another very popular cloud-native thing. And we like to refer to it as infrastructure as code. Terraform is owned by HashiCorp. It's not a CNCF project, but it is open source. And with infrastructure as code, using Terraform, you can basically take all of the things that you like, all of the resources that you need for your infrastructure, and put them into one file. In this way, it's like okonomiyaki. Okonomi o yaite imasu. No yona mono desu. So with this, you basically have a file that says, I want this many VMs, I want my network to look like this, I want this much storage. And then you just run that file using Terraform, and it goes and creates all of that stuff for you. So it's declarative style of running your infrastructure. It also allows you to make these resources much faster than you would be able to yourself because it's an automated process. And like I said, it's owned by HashiCorp. So I'm going to try to do a little demo now of that. If I can. That works. Well, that works. 見えるでしょあ持ってます大丈夫でしょうか見えるですかはい、それでは今のディレクトリはテラフォームのコンフィギュレーションです。この中にはたくさんファイルがあります。このファイルはね、見ましょうか。So if you look into one of these, we're going to be using Oracle Cloud as our example destination for this infrastructure, and we're going to be creating a virtual network today. So this defines the resource, a virtual network. It talks about what CIDR block you want to use. In Oracle Cloud, you have compartments where you keep your resources. Gives it a display name, a DNS label. So it has all of this information to describe resources in the cloud. Typing with one hand is hard. There we go. Okay. So here we are again with all of our Terraform files. And if we want to run this on our cloud, we can just run Terraform plan. And this will give us some information, if I spell it right. So first off, I need to tell it which region of the cloud I want to deploy into. I could have set this as an environment variable so that I didn't have to do it, but I want to tell it each time which region I want to deploy into. So that's why I didn't do that. And so when I do this, it goes through the files that it has and tells you what it's going to create and gives you as much information about those things as it can. For example, here is a subnet. It doesn't know what availability domain it will be in because that's going to be created when I apply. And it tells you what CIDR block this subnet will have, the compartment that it's going to be deployed into, the display name that it will create, and a few other things. So this is creating a lot of resources, as you can see, but it figured out what to do very quickly. So it's going to add 25 items, not going to change any, it's not going to destroy any. So if you want to change existing Terraform infrastructure, you can just change the existing files that you have and then rerun it, and Terraform will make sure that what exists in the real world matches the definition that you've created. So let's go ahead and run this. By running Terraform apply, and again, I have to specify which region. Okay. So that's going to be running for a little bit. And I have to tell it that I do want to do that, so yes. Why is this? Sorry. Technical difficulties. This is what's great about live demos. There you go. Okay, and now we're going to go to Oracle Cloud's console and log in. By the time I finish logging in, it might have already created the thing. All right, so this is what Oracle's cloud looks like if you haven't seen it before. There's a free trial available if you want to check it out for yourself. And we're going to go to networking and look at our virtual cloud networks. If you'll remember, that's what we saw in the file. And I believe that this is the new one. No, that one I created earlier. So this was created from this, the Terraform, and as you can see within it, there are a whole bunch of different subnets available. Oh yeah, it's UTC. So this is the one that I just created. So it has many different subnets. Some of them are private and some of them are public. It's also created an internet gateway, security lists, many different security lists. So it created a whole bunch of different networking infrastructure that I might need. And it did all of that in, as you saw, at the time it took me to actually log into the console. So that's what Terraform looks like. And I'm going to go back to the slideshow. Okay.
Oh, that's it.
Oh, sorry. I forgot I had them both up. Now I have to do the whole thing again.ごめんなさい。ちょっと恥ずかしいですよね。それではこちらへ。はい。And we're back. Oh wait, this one is the wrong slide deck again. I'm sorry. ちょっと失礼しました。ごめんなさい。それでいいですけど。プレゼンテーションはどこにいました？There we go. Okay. もう戻ってきた。So, foods aren't the only exciting things about festivals and amusement parks, though. So let's talk about rides and some other things that are important. First off, we'll mention events. So, an event would be something like something happened, an image got put into storage. And you can use that event to notify some other service that something happened. And this way you can create these automated pipelines of something happened and then it triggered this other thing to happen. So you can create a chain of automation within your cloud. This is a very key component of many clouds. So Oracle and Microsoft have worked together with the CNCF to create a standard format for these cloud events to take. So I wanted to go ahead and mention that. This is an ongoing project, so if that's something that's interesting to you, feel free to join in. And if we look at the diagram from earlier, this trigger would be the event that I was talking about. And it would have the CNCF standardized format, and then go talk to FN, which is, of course, open source, so you could be running it anywhere. And that's what events look like. And now, monitoring. So monitoring is kind of like the board at an amusement park where you can see how long you're going to have to wait to get on a specific ride. And it's like that because with your infrastructure in any cloud or even on-prem, you want to understand what's going on. You want to be able to see how much CPU and how much memory you're using. Often in a graphical form is best. So monitoring tools allow you to see how much of your CPU and memory and such that you're utilizing. And then it uses graphic tools to help you visualize what your infrastructure looks like. So examples of these would be Prometheus, which is owned by the CNCF, of course, and Grafana, which is a very common way to do the visualization of your infrastructure. Streaming and messaging is another key component of cloud-native architectures. In this modern world of big data, we have these constant streams of data that are coming in. And managing those constant streams of data is a challenge. So there are special tools that have been created specifically for managing constant data flow. And there are, of course, open source versions of those tools, such as Apache Kafka. This is a very common one, and it's what Oracle's streaming service is based on. But of course, it's open source, so anyone can use it. And then CNCF has a project called NATS for this purpose. And streaming and messaging services use databases to help manage that constant flow of data. So it's a pretty interesting area if you're interested in data flow. And actually, that is my last thing. How am I doing on time? Good? All right. Finished with 3 minutes, so pretty good. So thank you for coming to Cloudland, and I hope you learned some interesting things about cloud-native technologies.